Okay, now why would we care about something like that? So to kind of explain why, I want to show you here a program, okay? And this is a program called slow sort that actually sorts an array of elements, x's here, okay? And what we do is we hop in a loop, right? For i's in the range of x's, then what I say is that, and I want to show you kind of the picture that goes along with it. This is where I am in the loop right now, okay? That's I. So I go from 0 to n minus 1, right? And what we say is that this part here is already sorted. So we take this slot I, right? And what we want to do is we want to take the smallest element in I all the way up to n minus 1. I want to take the smallest element and move it here. Right? And then, of course, the loop will change to plus 1. Right? So we're always kind of finding the smallest element in the part of the list that I haven't seen yet. I'm moving that to the front. Okay, that's how this algorithm actually works. All right. So what can we actually prove that? Okay. Well, I'm not going to prove that it works, but what I'm going to prove is I'm going to tell you how many steps it takes. Okay. So here is my recurrence relation. A1 is equal to 5. How did I come up with that? Well, let's see. You know, I got that for loop. That's going to be like 1 comparison. I mean is equal to 1. To I rather. Okay, so that's another thing. J is in that range. Okay, so that's one more. Then I have to do this assignment. So yeah, that's 5 instructions. Okay. I'm assuming there that the array is of only length 1, so that I basically skip the inner loop. Okay. Now, otherwise, then what happens? Well, I need to do everything I did for the previous statement, but then I need to add some more things. In particular, I have that extra loop, so that gives me another 3n plus 3 statements, right? So A1 and A sub n, basically what this rule does is it counts the number of steps that I take when I execute this function. Initially, counting the number of steps is well, it's actually fairly painful, but it's doable when you're able to use the fact that in the previous iteration we took this much, right? So that you only have to add the additional number of steps one more time through the loop. So that's how we find recurrence relations. They're actually really, really common in computer science, okay? So, okay, I'm going to claim, right, that the solution to that is given by this. A sub n is equal to 3n squared over 2 plus 9n over 2 minus 1. Okay, like I said, that comes from magic, that comes from observations. That's usually the hard part. Okay, the easy part is to prove it. So let's do that. The base case, n is equal to 1. Okay, so what's a sub n? Well, according to this formula, it should be 3 halves plus 9 halves plus minus 1. And in fact, that is equal to 5. Okay, because that's 12 halves, which is 6 minus 1. Yep, that is 5. So check mark, right? We were able to prove the base case. Now, what about the induction step? Well, what's a sub n? That's a sub n minus 1 plus 3n plus 3. Okay, that's simply the definition, right? Right here. And so, oh, what's a sub n minus 1? Well, by the induction hypothesis, a sub n minus 1 is going to be this, right here. This is a sub n minus 1 by the induction hypothesis. Right? And we add 3n plus 3, that's just carried over from here. Now at this point, you just have to plow through, okay? The rest is true by algebra, so let's see if that's true. N minus 1 squared, that's just n squared minus 2n plus 1. Multiply that by 3 halves, and we get 3 halves n squared minus 6 halves n plus 3 over 2. Okay? And 9 times n minus 1 over 2, again, we'll just plow through that. That's 9 halves n minus 9 half. Okay? And now we combine terms, so we still have 3n squared over 2. So how many n terms do we have? We have 9n over 2 minus 6n over 2, that's 3n over 2, plus 3n, that's plus 6n over 2, that's plus 9n over 2, right? So all of these combine to give me that. And then I got plus 3 halves minus 9 halves, that's minus 6 halves plus 3. That's, well, let's see, try that again. That's actually 3 minus 9. That is 6. 6 halves. Oh, minus 1. There we go. So 6 halves minus 6 halves plus 6 halves, that goes away. And I'm left with just the minus 1 over here. Okay. So, like I said, this is just algebra. I'm not trying to demean algebra. Algebra can be difficult. Okay. But when you get to this stage in the proof, just have faith and use your algebra skills to just reduce everything. You should be able to come to this, okay? And remember, what I'm taking advantage of when I say that is the fact that this is a true fact, right? Somebody has gone through the trouble of finding it and given it to you, so you don't have to guess it in the first place.